So, in this video now we will move ahead from where we left in the last one. So, we were supposed to do now the computation of waiting time. Okay. And of course, for completing the context, we were actually talking about an output queued system. So, the packets are coming here, but there can be only one packet at any point of time, and my speed of vector I have taken to be n. So, in this case it will be 4, because the 4 n is equal to 4 in this case. In general, if they are large numbers, then this will be n. So, even if all packets which are there at the front, they want to go to the same port, they can be moved out in one single slot, because internally switch is operating at a speed which is n times the speed which is there on the line speed actually. So, the speed which is operating, it is n times the line speed. So, all packets can be moved to the outgoing thing. So, no packet buffering will be required at the inputs. At the output, we will have all the packets, all n packets will come up in one go. So, we actually had estimated what will be the queue length earlier, and that was given by q bar is equal to n minus 1 by n p square to 1 minus p. Okay. And of course, I told that this expression is for MD1 infinity q, okay. And when n goes to infinity, this q length will behave as if it is a MD1 infinity q. So, where the arrival is Markovian, remember, so packets being assumed to be arrived at any particular moment, but in reality packet only arrives in time slots, they arrive only periodically, and we do not have arrival rate, we define by set by p. So, p technically works as good as an arrival rate here. Okay. So, now let us look at the same thing, this is the queue context, and I have to find out what is the waiting time. If I tag a packet, I actually mark it, I put a marker on this and I observe this packet. So, what is going to be my expected delay? So, that is a question. So, what can happen to this packet? There will be W1 time slots. So, when this tagged packet is going to be moved, so for example, to this particular port, there must be already packets available which would have been transmitted in the earlier time slots. Okay. They would have been there. Then when this tagged packet will be done, it will be also, there may be other packets which may also be pushed along with it. So, delay can consist of two components. So, one is W1 we call it. So, in fact, total delay waiting time will be W1 plus W2. So, W1 represents is technically W1 time slots when packets arriving in earlier slots. Then the tagged packet will be transmitted. So, W1 is that part. Now, what is W2? Now, since there is a batch, there is a certain number which will be going there. So, they will be added. So, they will be added now, this was the earlier ones. So, this constitutes W1. Now, there is this batch, and say there is going to be I packets which are arriving. Your tagged packet can be anywhere, it can be in the front, it can be anywhere, and the W2 component is because of this. Okay, so we need to understand what is going to be the value for W2. So W1 is very much clear, is basically I have to find out what is the average Q length, and remember W1 and W2 both are independent, and W1 will depend on the Q which we had computed here. This Q bar essentially will give me this. So I know that W1, the probability generating, this actually has come from probability generating function Qz, which was 1 minus p 1 minus z Az minus z. So from here actually we got this Q bar. So this will ultimately will also be the probability generating function of W1z will be given by this. Now you have to understand that these are two independent random variables. This actually implies that W of z, PGF of W will be proportional, will be W1 of z into W2 of z. Okay. So whenever the random variables are added, you actually multiply their probability generating functions to get the final probability generating function. Okay. And Wz is nothing but Z transform of W1, W2z is Z transform of W2. Okay. So now let us try to find out what will happen to W2, how to find that thing out. Okay. So what we are doing is, I am actually assuming that we need to estimate the probability of tagged packet is in batch of I packets. What does it mean is, their I packets which are there in the head of the queue, they are being pushed out to the outgoing port. Okay. So how this will be find out? So a tagged packet will be in the batch of I packet if the remaining, so there is one packet which tagged packet which is already there, it is a conditional probability on the arrival of the tagged packet, remember. So remaining n minus 1 inputs should actually have I minus 1 packets directed to the same output port. So that is a conditional probability that you will have tagged packet in the batch of I packets. So which implies that I have to have n minus 1 C I minus 1, and since the arrival of a packet is P, it is directed to an outgoing port P by n. So a packet out of these n minus 1 is being directed to this port, that probability is P by n. So there are I minus 1 such packets which are being directed. So that is this probability, and remaining are not being directed to this, that is n minus 1 minus I minus 1. So that will be this probability. So of course now I can start solving it. So this will be n minus 1. So this turns out to be minus 1 will cancel out. So if I take this bracket, minus I plus 1, this one will cancel. So I will end up in getting only n minus I. So this minus 1 I can take care of by taking n by p out. Okay. So now I have to do is n by p. So I can take this n minus 1 factorial, I minus 1 factorial, n minus I. So I can take this n into n minus 1 factorial. So let me write it down. So, this I can actually write an I on top, and this will become I factorial. So, this will be nothing but I by P AI. This is the same AI which we had discussed earlier. In the earlier video, AI was NCI P by N so I ended up in having the same thing. So, it has become I AI by P. Probability that W2 will be is equal to K. So, I have already got the probability that you will be coming in batch of I packets. So, when you want a delay to be K, you should be at least in a batch of K plus 1 or higher number. So, if you are in K plus 1 batch, if you are in K plus 1, in that case you can actually have K packets which are coming in front of you. So, I am actually discarding these packets which corresponds to W1, I am not considering, but here you will have K packets in front of you and you are here, tagged packet is this one. So, you will be having delay of K, W2 will be K, after which you will be served, W1 will be because of the earlier arrived packets. It is possible that I may actually also have K plus 2. In that case, with equally likely probability this tagged packet can be anywhere, remember. Okay. So, when you have only K plus 1, your tagged packet will be present here, will be given, this will be happening with equally likely probability, it will be 1 over K plus 1. Okay. So, when it is K plus 2, this probability will become, because one packet will be here, you can be anywhere equally likely, and your tagged packet is present here is 1 over K plus 2 and so on. So, in this case I can write probability of this now can be written as 1 over K plus 1, the batches of K plus 1, AI of K plus 1 by P plus 1 over K plus 2 and so on till whatever the maximum batch size which can be there, which is going to be n where K will can take a maximum value of n minus 1. So, I can write down, so last expression will be 1 over n a n by P. So, I can write this as summation I is equal to K plus 1 to n 1 over I okay, this is what will be the probability that W2 will be equal to K. So, I can this I will actually cancel out. So, I will have AI by P. So, I can use this. So, in fact, now I can write it closely here and remove it from here. So, once I know the probability that W2 will be equal to K, I can use it to find out what is going to be W2Z and use it for finding out what is going to be WZ and henceforth what will be the delay. Okay. So, let us see what will be the WZ. So, you will have PGF for waiting time will be summation of Z raised power K 1 over P summation of I goes from k plus 1 to n, k goes from 0 to n minus 1. Okay. So, this has to be, remember, has to be n minus 1, because this is n, the last term is k will be n minus 1 for the last term. Okay. So, this will be W2Z. So, we need to estimate this. Now, AI is already known to me. AI will be given as 1 minus p by n plus z p by n raised power n. So, this, sorry, this is A z is already given to me. A I was n c I p by n raised power I 1 minus p by n So, now we have actually these 3, and based on this I have to find out what is going to be Wz. So, let us see if I can how to do it. This actually forms a last series, but we can still solve it without any issue. So, 1 over p actually comes out, remember it is a double summation now. So, I will take, first of all, k is equal to 0. So, I will have NC1, 0 plus 1 is 1, 1 over p has been taken out. So, I can now write down AI starting from k is equal to 1. So, this will be p by n the last value will be p by n raised power n. So, this is when k will be 0. Now, let me write down what will be k is equal to 1. So, this summation, so I will write it here. So, when k will be equal to 1, so I will actually add up with the second term here. In fact, let me add a second term also, that will be great. So, the second term will now be when k will be equal to 1. So, I will start with NC2 now, this term will not be there, I will be starting from here. So, every time I increase my k, my number of terms in this summation will start reducing. Okay. So, I will end up in now z will be multiplied, z raised power 1, I will have NC2 p by n square n minus 2 Similarly, when I will do for k is equal to 1, term will start with NC 3 and there will be z square in that case. Okay, sorry, there has to be a z here. So, next row will be with z square and so on. So, the last, in fact, I can write down here what will be the terms for z square. and so on for k is equal to till n minus 1. So, I have to just now do the sum up of this. So, I can write this thing very well as so this term will be the only term with I is equal to 1. Next one will actually have NC2 will have only 2 terms, 1 plus z will be there because of that. When you will have the third one, you will have 1 plus z square the last term will be 1 plus z square plus so these will be the terms. So, I can actually now write down the summation of these terms. So, in general if k is here, k is for a value of k, the series will be now 1 plus z square z of k minus 1. If I take the same k, because their k is 0, 1, 2, 3, here I have changed. K is equal to 1. Okay, let me take k is equal to this. So, I will take it as k. So, this summation, this is a geometric progression, and for this, so rule is the first term, the ratio which is z, ratio of total number of terms, which is in this case, in fact let me put k minus 1 here itself, so that I can corroborate with this particular number, or let us use it L minus 1. So, z raised power L minus 1 by z minus 1. So, I can very well replace most of these terms by, so 1 minus z will come here, one minus z cube 1 minus z, this one will be replaced by 1 minus zn by 1 minus z. This one actually is nothing but 1 minus z square by 1 minus z, which is 1 minus z and this 1 minus 1 plus z is coming. So, I will also write this thing as 1 minus z square 1 minus z. Okay. So, let us start solving it, what will happen. So, 1 minus z or z minus 1, I can do it either way around. So, for being consistent with my expression, or maybe I can do it this way only, not an issue. So, I can multiply this by 1 minus z by 1 minus z. Okay. So, once you do this, 1 minus z in the denominators can be taken out, which is common. So, I can write 1 over p 1 minus z and then of course all the terms with 1 multiplied by this, 1 multiplied by this, 1 multiplied by this I can add, and there those will become summation of NCI, I goes from 1 to n. Now there is also terms with minus z into this, minus z square into this, minus z cube into this. So those terms will be also going from 1 to n, z raised power I So I can very well multiply this z I can actually keep inside. Okay, this is what will be the expression. So I can, this one is nothing but 1 minus NC0 yeah, I made a mistake, there should be a minus here. So minus summation of I is equal to 1 to n Now since it is 0 I can put a z also, it does not matter, z raised power 0 is also 1. So this will turn out to be nothing but 1 over p 1 minus z 1 minus summation of I goes from 0 to n. So I am actually including this term also inside the summation. And this term is nothing but Az. So we can write this thing as 1 minus A of z divided by P 1 minus of z. So that will be your W2z actually. So once you have this, I can now solve it. So this will turn out to be, first one is Qz, so W prime of z, you take the derivative, put z goes to 1, that will be your W bar. This we had discussed in the earlier video. So this will turn out to be nothing but Q bar plus 1 over 2 p A square minus A bar. Okay. This is the second movement around mean, so that is a double derivative divided by 2 factorial. Okay. So you can always get it, you can so this one is actually comes from when you have z and you have pi, so this is a z transform actually. So when you take first derivative, you get when you get double derivative, the second movement and this will be so I can write it here, and when you take limit z goes to 1, so you have I square a I minus this is actually second moment, this is the first moment, okay, and that is what is coming up here when you take the first derivative, that is how it happens. Okay. I have not solved it, I am directly writing the relation. So, this is what will be the answer. And this is a more or less a standard result in any queuing theory book. So, your A square A bar will be equal to P, A square bar will be P square plus 1 over P by N, okay. So, your W bar will be N minus 1 by N Q bar MD1 infinity system plus 1 over 2 P and of course A bar is P, so it is minus P. This P will cancel with this one. So, again I am using the standard result from here, directly putting it. I have also written it in the earlier video. So, this one is again the standards which you can actually get it by using AZ, and this value will be P by 2 N minus 1 by N. So, you can actually solve it, N minus 1 by N can be taken out. This happens because of the finite size n. When this n goes to infinity, only this part can be assumed to be 1. So, this will give you P square 2 1 minus P. So, it is 1 by 2 it will be P minus P square. So, I can just add them up, P square cancels, and interestingly this one is also nothing but for the same Markovian arrival, deterministic departure, single server in finite size queue. This one is actually the delay for that particular component. Only impact which will be coming because of the batch arrival process is again n minus 1 by n. So, when n goes to infinity, this almost gives the same result. Otherwise, there is a small thing which will happen because of the discretization, because I am talking about the packet switching. So, that is how the output queuing actually behaves, they essentially gets converted to MD1 infinity for larger size switches.